Any other comments? Okay. Thank you, Sapir, again. And the next is Imri.
So I'll try to share screen now. So just to make sure you all can see my screen.
It's good.
Great. So let me just adjust some things here. Am I good to go, sir?
Yes.
Okay. So first of all, thank you, Sapir, and then thank you all. My name is Imri, and today I will present to you the bicep 2 experiment, or as I like to call it, I will take you through a journey between a discovery to disappointment by understanding the 2014 gravitational waves controversy. So let's see. So the layout of this talk is we'll give some background just to remind ourselves some basic physics and phenomena characteristics, some definitions, and then we will dive in to talk about the bicep 2 experiment. We will see what has happened there, what they were trying to do, and what they did. We will talk about their initial findings, the significance of those acclaimed findings, and then, of course, the turnaround to back down from these findings. Then we will see the outcome of this experiment, and we will talk a bit about the impact on cosmology of such experiments. So let's start. They say in literature that many good stories start with a bang, so our story starts with the Big Bang. So just to make sure that, to remind ourselves, the Big Bang is a physical theory that describes how the universe expanded from a primordial state of high density and temperature. I don't know if you can see my cursor, but just look on the left side of this diagram, right? The initial.
No, we
Where
cannot
do you
see
see?
the cursor.
Okay, so that's probably problem was my computer. Just look at the left side of this diagram, the initial state. We now move on to talk about, remind ourselves a little bit about the gravitational waves. Gravitational waves are waves of intensity of gravity that are generated by the accelerated masses and motions of gravitating masses, and they propagate its waves outward from their sources at the speed of light. Let's just think of it for intuition as ripples in space-time that are caused by violent and energetic processes. Let's definition first before we get along. So we will talk about the cosmic microwave background, the CMBs. So the cosmic microwave background, known as the CMB, is a microwave radiation that fills all space in the observable universe, as we can see in this diagram. It is a remnant that provides an important source of data on the primordial universe. The CMB, the cosmic microwave background, is an evidence of the Big Bang theory for the origin of the universe. So in the Big Bang cosmological models, during the earliest periods, the universe was filled with an opaque fog of dense, hot plasma of subatomic particles. As the universe expanded, this plasma cooled to the point where the protons and electrons combined to form neutral atoms of mostly hydrogen. Unlike the plasma, now these particles these atoms, they could not scatter thermal radiation by the Thomson scattering, and so the universe became transparent. This is the exact moment where we started seeing light, and this is the cosmic microwave background is the remnant from this exact motion. And so the universe became transparent, and this decoupling event released photons to travel freely through space. And however, these photons have grown less energetic due to the cosmological redshift. It means that they came from really, really far away, lost a little bit of energy. So this is associated with the expansion of the universe. So these were like the three main terms that I wish to talk about in the background. And we now move on to talk about the objective of the bicep 2 experiment. So this presentation will explore the initial claims, subsequent challenges, and eventual outcome of the bicep 2 experiment. The bicep 2 background imaging of cosmic extragalactic polarization experiment, it was designed to detect these primordial gravitational waves by observing the cosmic microwave background. So in 2014, the BICEP2 team, the team of this experiment, they announced that they had detected a specific pattern in this cosmic microwave background. And this specific pattern is known as B-mode polarization, which they attributed to gravitational waves from the early universe. For a pure B mode, just for us to get an intuition, the polarization is rotated by 45% with respect to the K vector, the wave vector. So models of inflation predict that inflation, how the universe expanded at the beginning, they predict that gravitational waves will source B modes of angular scales of a degree of larger B mode polarization, this polarization that we see right here, in a specific pattern of polarization that can be caused by gravitational waves from the early universe. So detecting such B modes in the cosmic background from gravitational waves, potentially offering a glimpse into just few moments after the Big Bang. So now let's talk a little bit about what this BICEP2 experiment is. So this is a ground-based cosmic microwave background polarization experiment, and it was conducted in the Amundsen Scott South Pole Station in Antarctica. And why they chose such a exotic place to detect, to make their experiment? And that is due to the fact that the South Pole is the ideal location due to its high altitude, dry air, in order to prevent from problem in detection due to disturbance in the atmosphere, and stable atmospheric conditions, which reduces noise and interference in the measurements. So their initial findings, they announced on March 17, 2014, and they announced that they had actually detected such expected B modes polarization patterns in the coronal mass in CMB. In the CMB, cosmic microwave background. And in the diagram right here, if you can see, it's really, I don't know if it's easy to see, but on the blue, we have some white pattern surrounding it. And we see that this is the location where they claim that they detected this pattern. So these patterns were interpreted as an evidence of primordial gravitational waves, a direct signal from the inflationary epoch of the early universe. So the region of the southern sky where this experiment, the BICEP2 telescope, observed the microwave polarization is shown here as the dotted lines, and I hope that all of you can see it right here in this diagram. So I now move on to talk about the significance of such discovery. So this on the same day as we said that they announced their findings on March 17, 2014. So in the exact day, the Scientific American has published a paper that gravity waves from the Big Bang were detected. And here they claim that a curved signature in the cosmic microwave background light provides proof of inflation and space-time ripples. And physicists have found a long-predicted twist in light from the Big Bang that represents the first image of ripples in the universe called gravitational waves, researchers announced today. And this was actually well-awaited and exciting discovery, because the findings is the direct proof of the theory of inflation, the idea that the universe expanded extremely quickly in the first fraction of a nanosecond after it was born. What's more, the signal is coming through much more strongly than expected, ruling out a large class of inflation models and potentially pointing the way towards new theories of physics, as experts say. So let's wrap it up. The significance is that if, as they claim, they discovered such a pattern, which really tells us what kind of inflation model one can use, it really is a game changer, which really makes the subtraction to a certain inflation model, which can then help us describe other models for new physics to describe. And please just look it up. And Mark Kamienkovski, he is a known cosmologist. He was not part of this experiment, but he was interviewed, and he says that this is actually huge because this is a great discovery. And as expected in this class, we now move on to the turnaround. So there were some challenges about their stories. So soon after their announcement, the scientific community expressed some skepticism and called for independent verification of the result. One of the primary concerns that was whether the observed B-mode polarization that they claimed that they detected signal was truly from primordial gravitational waves or from other sources. So the main suspect for other sources was dust contamination. One significant potential contaminant is interstellar dust within our galaxy, which can also produce such B-mode polarization patterns in the cosmic microwave background. Researchers pointed out that the BICEP2 experiment team might not have adequately accounted for this galactic dust in their analysis. And this has led to reanalysis. Subsequent reanalysis of the BICEP2 data, including comparisons with data from other satellites, the Planck satellite, indicated that a significant portion of the signal could be attributed to dust rather than these primordial gravitational waves. And the Planck satellites, which also the other team that helped do for the analysis, they operated the European Space Agency, provided a more detailed map of the sky, including this distribution of the galactic dust, as we can see here. And we can see that there is galactic dust on the way from the detection that the team did not account for. So the outcome is now that after such a reanalysis, they concluded that after thorough reanalysis and consideration of data from the Planck satellite, it was concluded that the BICEP2 signal was significantly contaminated by galactic dust. So the initial claim of detecting primordial gravitational waves, if I may say it, as you said before, the holy grail, this field of cosmology, it was retracted, and the excitement surrounding the discovery was tempered by realization. And in acknowledgement to what we discussed along this course, so the scientific process is what that has happened is that the BICEP2 episode highlights the self-correcting nature of nature. It is the peer review and independent verification that are critical for validating scientific discoveries, even though, as we saw during the class, peer review might not get the best results all the times. And the scientific community skepticisms and demand for additional evidence, this is what that has led to a more accurate understanding of the data. So the outcome is, after the mere excitement, it was published in Nature that gravitational waves discovery now officially dead. And the combined data from both the South Pole experiments, the BICEP2, as we discussed, and the Planck probe point to galactic dust as a confounding signal. So this joint work has shown that the detection of primordial B-modes is no longer robust once the emission from galactic dust is removed, says Planck astronomer Jean-Luc Pouget of the University of Paris. And so, unfortunately, we have not been able to confirm that the signal is an imprint of cosmic inflection. And if you remember that the known cosmologist Mark Kamienkovski said in the initial discovery that this is huge, here he mentions, I no longer believe that they detected the signal of gravitational waves. Such experiment impact on cosmology, such process and understanding along the way, what the cosmology community has discovered and learned from this process, in that this experiment's initial findings and subsequent retraction have emphasized the complexity of detection and interpreting primordial gravitational waves. So despite the setback, the search for B-mode polarization, it continues to be a major focus on cosmology, but now people are taking more constrained actions during their studies. And the episode has reinforced the importance of considering galactic foregrounds like dust in future experiments, as it was not a primordial thought of as we saw in the beginning. So the advancements since the beginning, since this experiment, is that the scientific community has since developed more sophisticated methods and technologies to filter out galactic dust and other sources of contaminations. And experiments like the South Pole Telescope, the Atacama Cosmology Telescope, and other upcoming missions such as the Simons Observatory and the CMB S4 project are continuing to search for primordial gravitational waves, but here in a more constructive approaches. And for future prospects, new instruments and missions aim to achieve higher sensitivity and better control over the foreground contamination. So the improved understanding that has come as a result from the contraction of the BICEP2 experiment, as we discussed, was gained from the BICEP2 experiment, have paved the way to a more accurate and reliable measurements. So, and future discoveries also could provide deeper insights into inflationary periods of the early universe, which we're trying to see, as we can see here again in the light of this diagram from the early universe, and in order to study also fundamental physics that are involved. So, to summarize, this experiment initial claims of detecting primordial gravitational waves generated significant excitement in the scientific community, as it actually expected. But the subsequent reanalysis revealed that the signal was largely due to galactic dust, leading to a retraction of the initial claim. And this episode underscores the importance of scientific process, including peer review, skepticism, and independent verification, and also thinking of all the possible ways that could cause some contaminants to your results. And the journey of these experiments from discovery to disappointment also highlights both the challenges and the robustness of scientific inquiry. And while the specific detection of gravitational waves from the early universe remains unconfirmed, the experience has contributed to the advancement of cosmological research techniques and methodologies. And the collaborations and efforts of the scientific community continue to push the boundaries of our understanding of the universe. And with that being said, that leads me to the next slide. Thank you.
Great, Imre, thank you. So this was an excellent example of how science should work. There is no misconduct, just wrong interpretation, and then by iteration, getting to a better science. Comments? I would like your participation. So there was nothing wrong with the data. Nobody manipulated the data. All the raw files, I guess, were available. It just the interpretation was wrong.
Yeah.
And then
they didn't take other account.
And then reanalysis basically, and asking some questions, basically caused the authors by themselves to retract.
Yeah.
Yeah. So this is exactly how science should be done. And we need some example like this as well in this course. Thank you. Other comments? If no other comments, then Zoachen, you go next.
I stop share.
Okay, do you see my presentation? You see it's going?
Yeah, we can see you.
Okay.
Can see.
Good. So, hello everyone, my name is Orchen, and I'm going to talk about the topic of does the MMR vaccine cause to autism. Basically, the MMR vaccine is the muscle mumps and rubella. In Hebrew, זה החיסון המשולש. So I choose this topic, although that it's not connected to my subject, what I'm doing on the lab. I think that the subject is very important. Basically, when we're talking about the last year, when you're talking about the coronavirus and the scare that goes all over the people here about vaccination, due to get vaccine or not, and there is a lot of statement that people say that it's really caused to some illness and maybe autism. And I think that when you read this article from 1998, you see maybe the start of all this myth that's going on. So before I'm going to talk about the article, I want to talk first of all, short introduction about what is this autism. So just move. Yes. So autism basically, it's autism spectrum disorder. Everybody knows it as ASD. And it's a neurological and development disorder that basically characterized with challenge with social interaction, communication, and repetitive behavior. So you can see it most of the time. You see it in the first 2 years of life of children. And sometimes you can see it even in the higher age, but most of the time you saw it in the earlier age. And what's important to know about autism is that in the last year, it has increased. You can see here that between 2006 and 2021, there is an increase of 20%. And it's something that's still going on. As we check the percent of the autism in the population, you see that it's going on. And the big question is what changed in those years? So basically, there is no good answer for what happens or what make autism for people, why people get autism. And the big question is what happened in those years that change and make it increase in these years. So because it's still an open question, so many people try to answer it, and some of the answers are not good enough. And now I'm going to talking about the paper. So as I told you before, the paper was published in 1998. It was by Andrew Wakefield. He was a British doctor, and he published the paper in the Lancet Medical Journal. And what he suggests in this article is that there is a link between the MMR vaccine and the autism. What happened after he published this article? Many people tried to do the research again and again in another groups, and they can't repeat the result. And in 2010 only, it's 12 years later, the paper was retracted. It was retracted due to serious ethical violation, and we're going to talk about it later. And what the problem is that although the article retracted, actually there is still a myth that there is a connection between vaccination and autism. And still there is a lot of people, parents that are afraid to take their children and take them to get vaccine, or maybe to not do it in one shot, to take and do it one by one. And there is really not a good plan for all the people. There is a lot of people that can't get vaccine for some reason, and this is the population that get affected because of people that don't choose to get their children vaccinated. So what happened in that article? So in that article, Wakefield take 12 children. The mean age was 6. There was 11 boys and only 1 girl. And all children have a history of normal development. And what happened after they get the MMR vaccination, they got symptoms that they got high fever, and some of them get high fever, some of them got ill. And what happens after that is that after some days, some weeks, I will show you the table, they diagnose as have an ASD. In the article, they say that they have the ethical approval from the hospital, the Royal Free Hospital, the hospital where Wakefield would work, and from the parents to do some tests. So what the tests that they did a lot of clinical tests. Some of them was gastro tests, some of them was imaging tests, and there was a laboratory test. I'm going to focus about the urinary melantonic acid. How does it affect? They saw that in the imaging tests, for example, there wasn't something that was significant between the children with autism and the other children. So let's go to the result. The first result is the melantonic acid in the patient and the control group. So what was the patient? You can see here that there is only 8 dots and not 12. They say that the 4 children, each one has something that because of that it can take the measurement from him. One of them broke the hand or something like that. So they have only 8 patients basically here in that measurement. And the control group was children without an autism. And they check the menatonic acid and they see that there is a higher higher menatonic acid in the patient group. So that's the first thing that make them think that maybe it's something that affects the children. The MMR vaccination caused to a higher menatonic acid in the children. The second thing, and the important one, I think, is the table that show, I think that this is the table that everybody gets scared from it. The table that show the diagnosis after the MMR, the diagnosis of autism of each children, and in the interval from the exposure to the MMR to the first behavioral symptoms. It means that when you get the MMR vaccination, after how much time you see some problem with the behavior of the children. So if you see here in the table, the time is very small. There was 1 week, 2 weeks, 48 hours, 24 hours, something that it's, when you look at the table, you say, okay, there is some connection. Maybe I didn't see that there is that this goes to that, but they see that there is some connection between those two. There is one children here that get for 18 months, but that's fine. The most of the children in a really short time. So before I'm going to talk about the article, it's worth mentioning that in the article they wrote that we did not prove an association between muscle mumps and robust vaccine and the syndrome described. So they didn't say that there is a association, that this got to that. They just said that there is some connection between those two, and they encourage people to keep going and search for that. So when you read the paper in the first time, you said, okay, this is a good paper. They say that they didn't found a real connection between those two, but it still give you some, I think, scary thought about, do I want to get my children to get vaccine or something like that? So what happened? The article caused noise in the scientific community, of course, and then there was overwhelming scientific evidence against the MMR autism link. There was a lot of article that's going through and checks millions of children and try to see if there is some connection. And there is a lot of group like the Center of Disease Control and other groups that try to, that did many research to try to find the connection that Weikenfeld talked about. And actually none of them succeed with, none of them succeed in actually see the same result that Weikenfeld sees. And none of them find the connection as he saw. And the big question was what happened in that article. So before I'm going to talk about the ethical problem that was in this article, I want to talk about when you read in the first round the paper, what the problem that you see. So the first one is the small sample size. You have only 12 children. The 12 children, all of them was in the lab of Weikenfeld, and all of them was in the same hospital, and only one girl. And then from 12 children, you say that you know something about all the children in the world. So it's something that is very small. The other article work with hundreds of children, something that it's more, you can say something about very high group instead of small group. And the second thing is that there is lack of control group. And what I mean when I'm talking about the control group, I showed you before that in the menatonic acid, there was a control group. But there was a control group that all the people in the control group was, they actually take group without people that are autistic. But what happened if you take another control group, the autism children that did not get the MMR vaccine, and then see what the menatonic acid in when you measure them. They didn't do that, and that's something that was missed when you compare between those two groups. What happened to the retraction of this article was not these two things, because these two things actually need to, I think, show in the review. And what happened is that 3 main things. The first one, and I think that this is the surprising one, that Weikenfeld actually paid to disclose that he had received funding from lawyers who interested in to sue the vaccine pharmaceutical. So basically he got he gets paid for publishing a paper that says that the vaccine manufacturers are not good. And that's what he did. And he didn't write it in the paper, of course, and he didn't say that. So basically, when you know that he gets found from these people, you know that the article basically will go to one place. The second thing is that the medical article, there is some allegation that Weidenfeld really don't get the approval that he should go. We should get from the parents or from the hospital. And the third thing is the misrepresented false data. So basically what he did, he exaggerated to fit the data. In the table that I showed you before, he said 24 hours, 48 hours, and basically it was not the case. So maybe the children really get ASD, but he didn't say the real time that they get that. I think that I need to say here, I show you before that ASD actually, you see that in children in the first 2 years, and that's exactly the time when you get vaccine. So to say that there is a connection between those two, you have to understand the short time between those two. If it's not that short time, so you can say that there is even a link between those two. So if I want to conclude about this article, so basically the scientific consensus is clear. There is no link between the MMR vaccine and the autism. And the myth is really not something that it's real, but it's something that stay in the community. People still think that there is some connection, or they're afraid. They don't know exactly, but they say that there is some claiming that there is connection between vaccination and some illness. And I think that here the article, the people that did the wrong thing here, not like the other thing that people talk about here today, actually affect on life. People didn't get vaccine, children didn't get vaccination, and then some diseases can go through, some virus can go through. We saw that in the coronavirus, some population that choose to not get vaccine because of some ideas, and it's really affects on the life of people. So we have a huge, maybe not in our topic, I don't know if somebody here is from biology or not, but maybe you don't affect people on their life, but sometimes it could really affect on life of people. And that's the end.
Great, thank you. So indeed, this is a very, very famous case which gave weapon to the anti-vax people till today, although it was proven wrong for many, many years by many people. It's enough for one person to say something, and then the whole world kind of picks up on this, and now to root it out is almost impossible. And this case was about money. The guy got money too, and he wrote what the financiers told him to write. So this is another famous case of misconduct. And I would love to hear your comments on this. Even today, anti-vax will use this case as an example why not to take vaccines.
I was surprised. Sorry. I was surprised that.
Go ahead.
Sorry. I was surprised that since it's working with humans, you have to get ethical approval, and I was surprised that when they submit the authors submitted that they want to do such research, they allowed for this research to be in such small sample of people and not diverged in only one girl. So I was surprised that
well, no.
I thought
basically
So
I didn't say it, but in ASD there is very small group of girls. Most of the children with ASD,
but you don't know what was. So it's usually you need to get what is called Helsinki approval. There is a committee, and you submit all the paperwork, and there is a committee reviewing it, and then allowing or not allowing you to do the experiments in humans. But we don't know what he put in his application.
Yes.
Compared to what he published. There were violations of the approval he got already. So I don't know that he was approved to do what exactly we see in the paper. He definitely was not approved to do invasive procedures in the kids, and he did.
Yes,
So,
there is a lot of picture that I didn't put here because I don't want to show you, but
yeah, so low statistics is always very difficult and problematic, but if you're dealing with rare diseases, it's difficult. Anyways, the main point here is the guy wanted to make, to earn some extra bucks, put in his pocket, and he published a paper that influenced the whole world till today. And it's very, very hard to undo. So that's another very famous case of unethical scientific behavior. Sapir, Zochen, I remind you, I need to get your PDF and PowerPoint.
I sent you the PDF. I will send you the PowerPoint also. You even comment to me.
Okay. And this is it for today. We have 2 more meetings next week and 2 weeks from now. Any other comments, requests? All right. If no, good night, Laila Tov for everybody. See you next week.
Good night. Bye.
Bye.
Bye, Laila Tov.